So extraction of metals, okay, is also same as we read about electrolysis process. So the extraction of metals by using an electrolytic process is called electro uh, metallurgy. Okay, if you see, electrometallurgy is generally used for the extraction of very reactive metals. Okay, mainly used for the very reactive metals such as lithium, potassium, sodium, magnesium, calcium, aluminum, etc. Okay, why? Because these metals have a strong affinity for oxygen, and their oxides, okay, and their oxides, the form in which these metals usually occur in nature, are highly stable. It is difficult and sometimes impossible to reduce their oxides by conventional reducing agents like carbon, hydrogen, carbon monoxide, etc. In order to extract these metals from their oxides, so also due to their high affinity for water, these metals cannot be obtained at cathode during electrolysis of their aqueous salt solution. However, electrolysis of their fused salt leads respective metals at cathode. Electrometallurgy provides a convenient method to reduce such oxide to respective metals. Okay, so why we use this extraction of metals? Because mainly these metals have a strong affinity with oxygen and their oxides are highly stable in nature. Okay, and impossible, sometimes it's impossible to reduce their oxides by normal conventional methods. Okay, so we are using these part C extra electrometallurgy. So some examples are given on your book also. So first is extraction of sodium. Okay, whenever you read this, you just remember the main concept of electrolysis which we discussed in last week. Okay, so extraction of sodium. Sodium is extracted by the electrolysis, or you can say electrolytic reduction of fused sodium chloride containing calcium uh, chloride with which lowers the fusion temperature of sodium chloride. So this is made up of iron. Okay, and while anode is made up of graphite. Okay, you can make figure also of that to understand. On passing electric current, okay, following reactions take place and sodium is obtained at the cathode. So it is normal things, we always already read the many examples of that, so that's why it's not necessary to explain again and again these things, that fused NaCl is just dissociated into its ions Na plus and plus Cl ions at cathode. This reaction take place, okay, where sodium in its metal form will be formed, and at anode chloride ions, so because it is not live in its individual form, okay, it has to be combined with another molecule and it forms the chloride molecule here. So sodium metal thus obtained at cathode is about 99.8% pure. So it means it's pure form of sodium we will be get by this method. And same for extraction of calcium. Calcium is extracted by the electrolysis of fused calcium chloride using an iron cathode and a graphite anode. Okay, the electrode reactions are as follows. So in this the same reaction occurs when we use this calcium chloride in fused state. It also dissociates into its ions, and at the cathode, okay, calcium metal is obtained, and at anode chloride occur in its molecule form. Okay, chlorine occur in its molecule form. Thus, calcium metal is obtained at the cathode. Next one is extraction of aluminium. Okay, aluminium is extracted by the electrolysis of fused pure alumina. Okay, aluminum oxide is Al2O3 dissolved in a fused mixture of cryolite. Okay, its formula is Na3AlF6. and fluorospar. Okay, CaF2 calcium fluoride is also known as fluorospar. So the mixture of cryolite and this fluorospar lowers the melting point of alumina and increase the electrical conductivity. Okay, what it will do, first thing is do that it lowers the melting point of alumina and increase the electrical conductivity. Next one, the electrolysis is carried out in an iron tank lined with gas carbon. This lining of gas carbon serves as cathode. The anode consists of number of carbon rods, okay, which dip in the fused electrolyte Al2O3 plus Na3 AlF6 plus CaF2. All three mixtures are there. On passing electric current, a following electrode reaction take place. So here also this alumina is just dissociates, okay, aluminum ion and oxide ion there, and at cathode aluminum is obtained and at anode oxygen is obtained. So the oxygen liberated during the process oxides the carbon anode producing CO and CO2 also. There carbon monoxide and carbon dioxide also formed, therefore anode needs to be replaced periodically. Okay, that's why we have to replace the anode, okay, after some time whenever this reaction take place.